heat waves shimmering over a farm. A sudden, intense monsoon flood. A close-up of a butterfly's wings. Upbeat, rhythmic music begins. In the fields, forests, and farms of India, a silent shift is underway. The smallest engines of our ecosystem are sending us a warning. Animated graphics over a map of India showing rising temperature graphs and erratic rainfall charts. Show a monsoon cycle, graphics spinning erratically. Climate change isn't just a story of melting glaciers and rising seas. It's scrambling the ancient rhythms of life. Rising temperatures, unpredictable, heavy rainfall, and chaotic monsoon cycles are fundamentally altering the world for India's insects. Animation of crop pests, like fall armyworm, appearing in new regions. Their activity, their feeding times, their very survival, is on the line. Vital bees, crucial for pollination, are now forced to forage in dangerously high heat or find their food sources have already wilted. Butterflies are shifting their habitats, moving to cooler regions. And critical crop pests are changing their feeding hours, catching farmers completely off guard. Transition to a shot of a scientist placing a small, high-tech sensor in a field. Data streams flow from the sensor to a laptop. But how do we track a problem that's often too small to see? We are now fighting a 21st century problem with 21st century tools. Scientists across India are deploying an arsenal of technology to listen in and understand this new normal. 1. 30150 close-up on a wireless sensor network, WSN, node. Animation shows it recording icons for temperature, humidity, and carbon dioxide. In fields, wireless sensor networks act as a digital nervous system. They record real-time air temperature, humidity, and carbon dioxide levels, giving us a minute-by-minute picture of insect habitat conditions and development triggers. An acoustic sensor is shown attached to a tree. An audio waveform graph appears, labeled pest chewing and mating call. Highly sensitive acoustic sensors can detect the hidden sounds of insect life, the specific frequency of a pest feeding inside a stem, or the mating calls that signal a population explosion. Animation of an infrared (IR) sensor scanning a field. Dots, representing insects, fly through the beams, creating a data map. They capture the backscattered light from an insect's body, allowing us to map flight activity and foraging movements, even in complete darkness. A farmer looks at a smartphone. The screen shows an app, like Farminaut, with a map, climate data, and a pest outbreak risk. High warning. All this data comes together on IoT and smart farming platforms. They combine live climate data with insect monitoring to predict outbreaks and habitat shifts, giving farmers the power of real-time decision-making. A person plants a strip of native wildflowers next to a crop field. First, we must promote pollinator-friendly landscapes, creating flowering corridors that provide food all year and strictly controlling pesticide use. At the same time, we must develop climate-resilient crops that can sustain pollinators even in harsh weather. A drone spot spraying a small section of a field, guided by a tablet. Instead of blanketing fields, farmers can use real-time data to monitor crop health and target only the problem spots. It's the core of integrated pest management, combining biological controls with early detection from sensors and AI-driven forecasting. Shots of researchers in a university and a government policy meeting. Text on screen. Support biodiversity and sustainable pollination. Finally, none of this works without support. We must strengthen research policies that make biodiversity conservation and sustainable pollination a national priority. Inspiring montage. A healthy bee on a flower, a thriving farm, a young scientist in a lab, a farmer smiling at their tablet, a beautiful wide shot of an Indian ecosystem. The solution lies at the intersection of science, technology, and ecology. Split screen showing a policymaker, a farmer, and a university student, representing a young scientist. To our policymakers, we need policies that support this smart, sustainable agriculture. To our farmers, embrace these modern tools for monitoring and management. And to the young scientists of India, your skills are needed now more than ever. Final wide shot of a healthy, vibrant Indian landscape. By combining technology with a deep respect for our ecology, we can protect India's rich biodiversity and secure our food future, even in a warming world.